Now we will discuss the types of natural resources. All forms of energy that we know on Earth come from a thermonuclear fusion from two primary sources, the Sun and the Earth's core. All other forms that are more obvious in our everyday life are derivatives of those two primary sources. For example, biomass, like wood, or methane, is captured through organic matter decomposition process. Solar energy, stored as a chemical bond after photosynthesis and released in a burning process. Fossil fuels are similar in their nature, since their origin is also from biological materials. However, their formation has taken millions of years, and their energy capacity is concentrated. Wind and water energy are fluid movements provoked also by the sun, and geothermal energy comes from the Earth's core and the fusion that takes place there. In this sense, all the energy comes from renewable sources. Energy could not be created or destroyed, but just transformed. However, the cycle of transformation may be a much longer period than a human lifetime. Both fossil fuels and biomass include burning processes. Nevertheless, the first are defined as non-renewable energy sources, while the latter are renewable, since the period of renovation is shorter than a human life. In many processes, for example, agriculture, metallurgy, or transport, we use resources which are not easily brought back to their initial states. It is a linear process of extraction, exploitation, and disposal which creates waste and pollution. On the other hand, when the product can be reused or easily brought back to its initial source materials, the line is closed to a circle, and we talk about a cyclic process, or recycling. Most of the processes in nature are cyclic. In this and many other cases, when we take examples from nature, which is the most sustainable system we know, we talk about biomimicry. Most of the conventional energy sources, material processes, and material manipulations include carbon and create carbon emissions. This is what we define as our carbon footprint. Carbon is easily bound to oxygen in burning processes, including metabolitic processes. The reversibility of carbon dioxide compound is solved by nature through the process of photosynthesis, a chemical reaction that takes place only in plants and which requires solar energy to store carbon and liberate oxygen in the atmosphere. The carbon cycle is important for the planet because the carbon dioxide compound, or CO2, creates a greenhouse effect in the Earth's atmosphere. Solar energy penetrates, but it cannot be dissipated back into space. Warmth accumulates and changes the climate on the planet, making it habitable. However, the levels of CO2 in the atmosphere today are much higher than they would normally be under natural conditions. Scientists are certain of humans being responsible for the current increased CO2 levels in the atmosphere. Fossil fuels, which contain carbon, that had been stored for millions of years, are being burnt intensively just within a few decades. And this process liberates enormous amounts of CO2. And because storing carbon back would take much longer time than releasing it, we talk of waste and gas pollution. Apart from gas pollution, many processes include the usage of water or solid materials, including chemicals, organic compounds, and others. These processes may be very complex and may include hundreds of thousands of input parameters to get the full picture. In order to estimate the effects of a process or a product on the environment, designers perform the so-called life cycle analysis, which gives comparative criteria, usually in terms of CO2 emissions, for the product or service analysis.